Yes, sir. I'm ready.
Okay, so before to start, good morning to all of you, dear students and our resource person for today. Uh, Firstly, I will give the brief introduction of the sir. Sir has completed his PhD from NIT Surathkal last year in the field of IoT. And before joining PhD, sir was assistant professor in our university only. And after completion of the PhD, sir was associate professor in Geetam University. And after that, sir has joined the CDEC Bangalore, one of the central agency for the computation work for government of India. And sir is their senior project engineer, and sir expertise is purely in the field of IoT. And in the IoT, mainly security and protocols. So sir has very vast experience because of lot of collaboration sir have already done in the IoT field. Very, you can say, very reputed journal publication has been done by the sir. So sir has very sound knowledge. So I request student to be interactive in the session. And if anything, any kind of thing, if anyone want to ask, then they can ask here. Immediately you can ask or after the session also. So thank you very much, Vishal sir, for accepting our invitation to deliver talk here. So now I request you to start the session, sir.
Sir, can you just start the recording?
Yes, surely. Vishal sir.
Yeah, I'm here only. So, thank you, Nilesh sir, for inviting me as a expert, right? And good morning to all of you, right? So I gave me the my introduction. That is fine, but the mainly thing is that when you work on any specific technology, right, especially IoT or any other technology that you want to work,
Vishal
you
sir,
need.
your screen is not visible, sir.
Yeah. It's not fair right now, sir. I'm just
Okay, sir.
speaking.
No, sir. No.
Yeah. So if you want to work in specific technology, right, in detail, then you have to be patient and fully dedicated that you might get some hurdles in it, right? But when you are spending some time on the particular problem, you will get a solution. Definitely you will get a solution. So let's start uh, by this presentation, right? So is my screen visible to you?
Yes, sir.
Yeah,
Yes, sir.
okay. Yeah, thanks for knowing me. Let me know. So now, before starting, right, it specifically talk on the application layer protocol and its simulation. So before starting it, that I want to ask few questions regarding the protocols. First is that why we need a application layer protocols, because especially there are several application layer protocols are available, right? Why can't we use those protocols in IoT? Can anyone answer me?
It can be used to send data and use network related things.
Yeah, but that already built protocol, right? Already available, right? For a LAN networking that you heard about TCP, sorry, HTTP, FTP, right? All our application layer protocols are available. So why can't we use those protocols in our IoT protocol stack? Is there any specific reason for that? Let me give you a hint, right? Then think about it. Mainly thing is that it's related to your devices that you are using, IoT devices. So now, can you get an answer?
Sir, basically, there is a different environment. So, the same protocol for such as TCP/IP cannot be used in IoT for IoT devices communication.
Yeah, correct. The one first one is correct because of the environment, right? The second is that TCP right? It will be used because it belongs to the transport layer. That's fine. But the main keyword is that because of the environment. So basically the normal application layer protocols that you use, it belongs to the LAN environment, right? And especially for wireless, but it's not for basically the keyword is called the constraint environment, right? What is the meaning of constraint environment is that you have a limited bandwidth, you have a latency problem, right? And the main thing is that whatever the IoT devices you want to use, right? A tiny IoT devices that is belong, right? That belongs to the constraint devices. Constraint means it has a problem in terms of power, it has a problem in terms of memory, right? And many more. So this type of devices can't handle the normal application layer protocols. So what the IETF, the Internet Engineering Task Force, and the core networking group, right, which belongs to the IETF, it developed a specific application layer protocol that is specifically designed for constrained devices. So let's start with one of the main protocol, which is called the CoAP, right, the Constrained Application Protocol. So this is standardized by the IETF, right, Internet Engineering Task Force, and its RFC is RFC 7252, right? It's available, and my whole PhD work is on the CoAP protocol. So before starting this application layer protocol, the mainly thing is that they categorize the application layer protocol based on the communication model, right? So which are the communication model available, right? Can anyone know? The communication model. Okay, fine. So now the thing is that the communication model, right? They are basically four, or not four, many more, but the categorized mainly is first is the request response, right? A request response communication model. Second is the publish subscribe communication model. Second, third one is the push pull communication model, and the fourth one you can say that the WebSocket based communication model, right? Many more communication model are there, but based on this four communication model, right? The application layer protocols are categorized. So first thing, the constant application layer protocol, right, belongs to request response communication model, right? Now the main thing is that we will start with this presentation with the overview, then which are the various implementation, and at the last, after explaining all the application layer protocol, I will give you a small demonstration of the CoAP using the Contiki operating system. So let's start with the CoAP. Now the main thing is that it belongs to the HTTP plus REST representation state transfer. The first thing is saying here only. So what is HTTP plus REST? That all of you know that HTTP is a hypertext transfer protocol, right? It belongs to the application layer protocol, and its top of its follow the representation state transfer, right, architecture, right, or framework, you can say that. So mainly whatever things you are doing through the browser or anything, right, that commonly you are using the HTTP request, means you are sending a request to the server, right, and you are getting some response, right, from the, suppose for example, if you're trying to search some web page, right, you are just typing in the URL in the browser by typing the URL, right, starting with HTTP or HTTPS. HTTPS belongs to the secure, right? So once you send the request, right, then there are several processes, right? First is find the DNS, it will look up the name, and then whole process, I think you already learn in the networking field how the request will be sent and response to be get. So I'm not going into the deep, but it will be the normal communication over the internet, right, using the HTTP. But the main thing is that behind a transport layer, HTTP use the transmission control protocol, right? So now the thing is that HTTP is only handling a request response, right? It is not handling the remaining part that you need, right? Because TCP is already provide you, like suppose reliability. If packet gets dropped, what you want to do, right? If packets get dropped, what you want to do? Then TCP will apply reliability. Suppose you have a vast number of packet drop and you want to apply some technique which is called the congestion control, right? Means that will be congestion at the router, right? So queue will be full, buffer will be full, and your packet has been dropped. So it's called congestion, right? So how to treat the congestion, that TCP has already know. So you don't have to worry about anything because TCP will provide the functionality. The only thing, the request response things you have to handle by HTTP. And one more thing, third point, is saying that leverages the features of HTTP such as persistent connection. Now, can you tell me what is the meaning of persistent connection? Can anyone tell me what is the meaning of persistent connection? Okay, so the persistent connection means it's always open. Like suppose, let's say, see by using an example. Suppose now I am a client, you are the server. So before communicating between us, okay, I just create a communication link, right, between me and you, and then once you accept the communication, right, then my connection will be open till we close the connection, right? So once you open a connection, my connection will be open till I said that now all the thing is done, let's wrap it up. Okay, so this is called the persistent connection, which is constantly open. But IoT, right, in IoT, because of the constrained nature of the network or the constrained nature of the devices, this persistent connection is not suitable. Why? Because see here below, the IoT networks characterized as a low power and lossy networks. Now what is the meaning of low power and lossy networks, right? LLNs. So basically the devices are deployed in a remote area which is constrained network. You can say that constrained networks, and these devices have a low power because they are battery operated. So they cannot consume a huge amount of power. If you run a large amount of application on top of it, the battery has to be drained. At the end, if possible, I will show you some devices which is battery operated, right? And what is the lossy network? Lossy network means wireless networks, right? For example, wireless networks. So inside that normal LAN connection, wired network, there is a persistent connection you can get using LAN. But all of you are facing something problem like when you have a Wi-Fi connection. Sometimes you find that you cannot get a connection. Still your Wi-Fi is connected, right? Your Wi-Fi is connected, but still you are facing a problem that I'm not getting an internet, or I'm not getting I'm not able to open some links or like this, right? So lossy network means this wireless characteristics are that, and it happened because of link failures, right? Because this IoT, small IoT devices are deployed in a remote area, constrained networks, and they are communicating through wireless communication protocols like Wi-Fi, Bluetooth, Zigbee. Yeah. So it may be happen that link failures. That's why it's called a network as a low power and lossy networks, because of devices are battery operated, as well as in wireless networks the link failure happens, so it's a lossy networks, right? And the main thing, now the next bullet you can see that low memory and computing power because of constrained node, right? Because battery operated is there, and each and every IoT device has a limited amount of RAM and ROM. So if you are familiar with any simulator or any mode like Sky mode and Zolarita mode or any mode, right? You found that each and every device, just check the data sheet. Data sheet is content. The meaning of data sheet is that each and every mode has a data sheet. It will give you a full configuration about this mode. So each and every device has a limited amount of RAM and ROM, right? So because of that, it's got low memory and computing power, constrained node. low bandwidth and lossy wireless channels. I do not have to explain, right? I already explained that. And then TCP maintains states for every open connection and becomes too heavy. Now, this line has to be understood very good. So now what is the TCP maintains states for every open connection? Now suppose I am able to, you want to, I want to able to communicate, I want to communicate with you. Okay, so what I will do, what TCP will do, TCP will do three-way handshake, correct? Three-way handshake to do the communication. Now for every open connection, it maintains the state. Suppose I am communicating with you, I am also communicating with other people, I am also communicating with other people, right? So what it happens? For every connection, three-way handshake happen and it's maintained the state, right? It maintains the state information for every open connection inside it. So now, if you want to use that in IoT networks, right? Because devices are very small and constrained, and if you store this many information on the devices, it becomes heavy, right? It becomes heavy. So the main thing is that you cannot use TCP as it is. You cannot use TCP as it is like you use in wired network. That is the one solution. Wow. Then what are the changes we have to made in TCP? That we will see. Now the same thing is that IoT traffic is event based. Event based means event driven traffic. All of you know that event driven traffic means when the event occurred, then and then communication open. Once event is over, done. Communication is done. We don't want to communicate, right? So that doesn't require a persistent connection always open. If you open the connection always, right, what happen? Battery has to be drained continuously, and after some time, your device, you are not able to communicate with your device. So that is because of this TCP and persistent connection is not useful. Now the next question is that these are all the things are constraint and limitation. Then we can't use HTTP, we can't use TCP. Then can we have a lightweight application layer protocol for IoT? Yes, we have, which is called the CoAP, the Constraint Application Protocol. So CoAP is an application layer protocol for constraint nodes and network, which is already standardized by the IETF in RFC 7252 co-working group, and is specially developed for machine-to-machine communication, right? Machine-to-machine communication means end-to-end communication, the device-to-device communication you can happen. Now the main thing is that why we need this, right, CoAP if we have a HTTP, right? We can reduce the HTTP functionality and we can use it, right? But the main thing is that you cannot, because HTTP use TCP, underlying transfer protocol, and you have to reduce some functionality of HTTP and again reduce some functionality of TCP. So you reduce two protocols functionality, then you can use tool. No, that is the wrong way, right? So that's why they build with the lightweight application layer protocol, and it has the same functionality like request response model. So if all of you know how HTTP works, clear, then you can easily understand that how CoAP works, correct? Then main thing is that it runs on top of UDP, right? It runs on top of UDP, clear? So user datagram protocol is there, but it's not limited. That CoAP, right now the latest research is going on that CoAP it works with TCP too, right? It's going on, but you cannot use as it is TCP's functionality. You have to reduce or trim some of the functionality of TCP, then you can use it. Now next is which are the features of the CoAP. Then first is asynchronous message exchanges, right? Asynchronous message exchanges means you cannot have a what we call that asynchronous message exchanges means once you send a request, right, you have to get a reply. Until that you have to wait. That asynchronous message exchanges. Next is a low header overhead, because CoAP has a minimal of 4 bytes of header, right? 4 bytes of header. So you cannot worry about that it have a large header and you cannot fit into this. You can fit it because you UDP is a connectionless protocol, and on top of that CoAP is work, and it has a very minimal header, 4 bytes sort of. We will see which are the things in the header in the later part, and same methods that HTTP supports: get, post, put, delete. Right now, the main thing is that which are the message type that CoAP supports. Right, because CoAP is works on top of UDP. Right, it cannot work on top of TCP. So now that it is not working, not cannot, it is not working on top of TCP. So 4 types of messages that CoAP supports. First is confirmable, next is an unconfirmable, acknowledgement, and reset. Clear? So we will see one by one this messages how it works based on the diagram, right? As well as other things. So now working of CoAP layer. So as you can see that CoAP is application layer protocol which works on top of UDP, but it has a 2 layers. CoAP has first is a request response. So what is request response is doing is manage the interaction between the devices, right? Means once you send a request and get a response, so this type of communication will be handled by request response layer, and this messages, right, which asynchronous messages transmission, right, which will be handled by this messaging layer, right? So the main thing is that server has to respond the request whatever you are sending, right, from the client's letter when it is ready. Means the server, suppose if you are sending a request, right, when a client is you are sending the request and server is busy, okay, but the server has to respond the request. It cannot say that it cannot send a request, sorry, it cannot send a response to the particular request, right? Once the client is ready, suppose client is busy in communication with other devices, it has to wait and send a response. It is not like that. So these are the images I have taken from the step-by-step guide. This is the URL of that. Now the next is let's start with the message type. What is the confirmable message type? Right, the first. So confirmable message type in a TCP, when you capture the packet using the Wireshark, you find that the confirmable message is the ID 1. Right. So as you can see that client and server are communication. So there are 2 ways to do. Once a client sends a confirmable message with the specific message ID, this is the same message ID, right? It is used by TCP connection. It is a sequence. So this is a confirmable message with ID. This is sending by client to server. Hello. Any doubt? Okay, and now server has to send a acknowledgement, right? So main thing is that confirmable. Hello. Hello. Okay, so now when the client sending the confirmable message with the message ID, server has to respond with the acknowledgement, right, with the same message ID. So once the client send a confirmable message, right, client cannot send the confirmable message again, next confirmable message, until it gets the acknowledgement. So it maintains a reliability, right? It maintains the reliability like TCP is using. Once you send a packet, you will get an acknowledgement from that, right? The same way, because CoAP works on top of UDP, so CoAP itself implements the reliability at application layer. So once what is the confirmable message is doing? Once you send a confirmable message, client has to wait for the acknowledgement, right, until the timeout. Once the timeout happen, means specific time is dedicated for the message. If until means using that time, if you cannot get acknowledgement, your packet has to be, your transmission has to be cancelled and packet has to be retransmitted, right? Because you cannot get an acknowledgement, right? So maximum three retransmission happen, and after the third retransmission, if you cannot get an acknowledgement for particular timeout, right? What happen? It will discard that, means consider that transmission as a failed and again restart from the scratch. Clear? So this is the one way to do it. Now the main thing is that server can also reply with the reset message. Now the suppose is that when the client sending a confirmable message, clear, and the server, right, is not ready. or server has some problem, it's not able to get a request or whatever thing, then server will send a reset message to the client. But main thing is that here, when the server is sending the acknowledgement, same message ID will be used, then and then client can understand that this acknowledgement belongs to which message. That mapping by using message ID. Now in reset it is not happen. Simply reset, it is fine. Next is a non-confirmable. So non-confirmable simply like spray and wait, right? You don't need any reliability needed, right? And you cannot get any response for a non-confirmable message. Only sending a non-confirmable messages and wait for the acknowledgement whether you are getting or not. It's not guaranteed, right? And when you capture this packet, you will get the Wireshark in Wireshark info. The ID number is 2. Now the next packet is how the request response has to be sent, right? So as you can see that here, excuse me, client sending a confirmable message with the message ID. Now client sending a get request and want to know the pressure value, right? What is the pressure value, or you can say that any thing like temperature value, because we are using the devices and devices inbuilt have a sensors or whatever. So you can send a request and know the value of temperature or pressure or anything, right? So you are sending the get request with the URI of that, right? A pressure value, right? With the token, right? Now once the acknowledgement has been sent, so acknowledgement with the same message ID, with the value and with the same token. Clear? If the acknowledgement is not ready right now, suppose server is processing, you are sending the request and server is processing the request, then, right, it will send a empty acknowledgement. It is not having this value, only acknowledgement. And that meaning of acknowledgement is that yes, I can have your request, but it still needs some time to process it. So this is the acknowledgement of this, I am getting a request, right? So it's not having a value, only the message ID should be there. Now this is the way. See, if server is not able to ready, empty acknowledgement with the message ID, no value, no token. But once it is ready, server is ready, clear? So how can we proceed? Now server is sending a confirmable message, right? Server is sending a confirmable message with the new message ID, right? With the value, right? And this time client has two acknowledgement with the same message ID, that I get a response from you. Clear? Clear. So if the client is, instead of confirmable, if the client using the non-confirmable message, then the server will follow up with the non-confirmable message. It's not like that. But the main thing you have to understand, that the main task is that, note down is this, why we need a token value here. Here, why we need a token value here? What is the importance of token value? Because CoAP has a two features. One is the message ID and another is a token. So this is your work to find out why the CoAP need a token value. Okay. Now let's move on to the header format. So as you can see, that is a 4-byte header. So first 2 bits will be allocated for the version. Version means the CoAP version. So it's a 2 bits, means as you can see that if you convert to the binary, it will be the 00011011. Clear? So now the thing is that based on the version, it will always when you capture the CoAP packet, you will find the version mainly about 01, right? Whatever version you are using, it is fixed. 01 is there. Then the T is indicating the message type. Clear? It is again 2-bit, right? So 0 for confirmable, 1 for non-confirmable, right? 2 for acknowledgement, reset, like this. So again 00011011, this type of unit, 2 bits are allocated for that. Token length field, right? It's a 4-bit field. It is used for the token value. This is a token value. You have to find out. I have given a task that to you, that what is the importance of token in CoAP. Then a code. This is code is using something like 8-bit assign, which is used in response, right? Like you can set, you heard about that. When you are sending a HTTP request, if you go through the HTTP protocol, you are sending a request and we will get some response with the ID 2.2.05, or if you have any server error then 401, then any sorry 501, then client error 401, right? This type of code you are getting, the same code used by the co-op also, right, which is a code field, then message ID field, this message ID, clear? And now the token, this carries the actual token, this is the length, this will represent the length of the token, this will actual token, and several options are available. So if you go with the HTTP and find that if match, if unmatch, there are several options available. Am I correct? If you go through with the HTTP, you will find it. So these options are already available with the co-app also. And last is the payload. Payload means the packet or message that you are sending. So this is a header format, co-app header 4 bytes, and these are the papers that I have worked on it, right? First is the Cocoa++, the daily gradient based congestion control mechanisms for IoT, and other 4 papers are also there. This is recently accepted in ad hoc network. This is FCCS. So my mainly work on the co-app and especially in congestion control mechanisms, and these are my work papers. Now next move on to these are basic things, right, that you should know about the co-app. If you want to go into the detail, you have to study, right? Next thing is implementation of co-app. So as you can see that there are several implementation of co-app available. It is not fixed that if I am using a C or someone is using a Python, then you should also use the same thing, right, to implement the functionality in co-app. No, right? There are several implementation of co-app is available. If you are good in Java, if you are good in Python, if you are good in C, if you are good in command line in interface, if you are using with smartphone applications like Android or iOS, right? Various application or implementations, sorry, not application, various implementations of co-app are available based on your choice, based on your mastery in the language. You can choose it, right? This is a site, https coap.technology slash implementation imples.html. You can find it, clear? Now I will show the later, this part later, right, once we finish this application layer protocols. So now these are the done. So let me start with this new protocol. Any doubt in this protocol, co-app? Any doubt? If you are not understanding and whatever I am explaining you are not getting, just ask me. Okay, so no doubt from your side. So let's start with the new protocol, which is called the MQTT, which is message queue, M for message, Q telemetry transport. MQTT is specialized for protocol for M2M and IoT applications. Now, previously before starting this lecture, I told you based the communication models. First is which are the communication model I explained? The terminology term. Can anybody know? Can anyone tell me? Which are the communication model? I just explained name, the name. I'm not explaining detail. The name. Before start this lecture. No?
Request response.
Yes, correct. So any other than request response? Any other than request response? Have you remember?
Push.
Push
Correct.
pull. Correct. Push pull.
Push
Right.
pull. Yes, sir.
Push pull. Correct. Correct. Now the next thing is any other than that? Third one. So we go to request response, which is co-op. Right. Now the next is someone is say the push pull. Correct. But one more thing is that one more name is that which will it? It's a publish subscribe. Clear? Publish subscribe. So let me give you a brief introduction about publish subscribes by using an example. Then you will get to understand what is the meaning of publish subscribe. Now, all of you are using a YouTube channel, correct? Using a YouTube, not channel. All of you are using a YouTube. Clear? Now, many of you are following PUBG Mobile, right? Or any other famous YouTubers, right? Either a blogger or anything. So always you are watching that YouTube's videos of the PUBG Mobile or FIFA Mobile, right? And BGMI, clear? And any other YouTube blogger channel. So if you are admirer of that channel, what you are doing? Can you tell me what you are doing?
We subscribe it.
Yes, correct. So you subscribe that channel, and if you subscribe that channel, what is happening? If you subscribe that channel, what will happen? Can I?
Sir, whenever new videos or something come, then we
Yes,
get a
yes.
notification.
Correct, correct, absolutely correct. So now, if you subscribe to that channel, whenever any video of FIFA Mobile or PUBG or BGMS, right, everything will be there, or any YouTuber will upload a video or anything on the YouTube, you will get the notification and you see that, right? So now, same time, here what happened? YouTuber, whatever, whoever uploading the video or anything, that will be the publisher, right? Because it publish, well, it publish. Now, publisher is only one, right? YouTuber, blogger, or anything, clear? But there are more subscribers, clear? Subscribers, clear? You are all the subscribers. Now, how the publisher will publish and you will get the notification. So for that, you need an intermediate which is called a broker, right? Which is called a broker. Broker is nothing but a YouTube. As an example, if I take an example and explain to you, so publisher will be your YouTube personality or whoever uploaded the video. You are the subscriber, like you, so many subscribers are there, and you are the broker will be your YouTube, right? So YouTube will handle all the things. So YouTube have a information about the publisher also, and YouTube has a information about subscriber also. Clear? Now the main thing is that, right, you subscribe to particular channel. So it may be happen that one particular publisher or YouTuber has a several channel. Like he upload the video for football, he upload the video for PUBG, he upload the video for vlogs. Clear? Different channels are there, right? So now, suppose you are only admirer of the PUBG or BGMI, you subscribe to the BGMI only. Clear? If someone follow the same publisher, but it admire about the vlogs, right? So he or she subscribe to vlogs channel only. Clear? Now, each and every channel has some name, right? Like PUBG, for example, PUBG, vlogs, right? These are the names. So once a publisher publish any video of suppose vlog, so it will use the keyword vlog, right? Which is as a terminology in MQTT, it is called a topic, right? In terms of MQTT, it is called a topic. So publisher will publish a video or anything on particular topic. Clear? Like vlog is a topic, like PUBG is a topic, like football is a topic. So these are the topics. So publisher publish any video based on the topic, and those who subscribe to the particular topic, right? Those who subscribe to the particular topic, they will got the notification. Like out of 50 people, 10 people subscribe to BGMI and other people are not. So only 10 people get the notification because they subscribe to the BGMI topic. They are not subscribed to the other topic, right? Other people will subscribe to the vlog, so they will get the notification of vlog, not the BGMI. And you are not getting the notification of vlog because you subscribe to the BGMI. Clear? So based on the particular topic, right, you have to subscribe to particular topic, and a broker, which is a YouTube as an example, it will handle these things, all the things. Which subscriber subscribe to which topic, publisher is published on which topic, can send the notification, all the things will be handled by your broker. So this is before starting this protocol, right? I just explain it by using an example. So once I start this protocol, you have an example in your mind and you will easily relate to this example and you will get it quickly. Correct? Hope all of you are understand this working of MQTT. Okay, so let's start with this. So these are the contents. Let's move on to this. This is a MQTT. I already told it is a lightweight message queuing transport protocol. It is developed by IBM, right? And IBM just first use the MQTT, right, to send an sensors data and actuators data. Clear? So you can see that here the MQTT broker is that. These are the sensors nodes, these are the actor nodes, right? Two nodes are that, and several applications are running either wired or wireless environment, and these applications are sending the data to the broker. So sensor node will send the data and this application will get it. This application will send a notification or anything will be needed. Actor node will work as a what you can say that activation messages, right, to the blind actor node. So application will send a messages to the actor node. Sensor will publish the sensors data. So these are the basic communications happen, right? So as you can see that here the light sensor continuously send the sensor to the broker. So this suppose sensor node has a light sensor is continuously sensor data to the broker. Now building a control application receive the sensor data from the broker. These are the application receive the data from the broker, clear, and activate the blinds, and this blind will be applied a broker actor node. Now key features are that 2 bytes of header are there, PubSub model are there. So as you can see that broker maintains the several topics. So once the publisher publish any message to the particular topic, right, it will get to the particular subscriber only. So this subscriber will subscribe only the topic number 4. Sorry, I cannot have a mistake here, subscriber. So this subscriber have a subscribe to particular topic 4. So once this published on 4, it will get, it cannot get a 1, right? So to subscribe for 1 and 2, it will get it. So likewise it will work, right? So IBM is developed, the first version is 3.1, and now it will be handled by MQTT.org. Now it will be handled by Oasis, clear? Official standard Oasis, right? It's version 3.1.1, and basically it works on top of TCP, correct? It works on top of TCP. So these are the MQTT models are there. So as you can see that there's 4 elements of that applications which are using sensors, temperature sensors like this. It has a client, MQTT client, right? Either publisher or subscriber, right? Broker will be have several topic and client subscription message. All the things are here only, and the transport layer, as you can see, that TCP/IP. Whatever things is happening here, MQTT sessions will be created and message has to be transferred and received. Underlying TCP will be used and TCP/IP network will be used. Now, same model, as you can see that client, publisher, subscriber are special roles, topics are there, right? Publish, subscribe pattern, correct? Broker through. Now the main thing is that how sessions should be handled. So as you can see that subscription session how can be handled. So unlike a sessions, that subscription logically attaches a client to topic. So when a client is publish something, it attaches with the topic, and when subscribe to topic, when subscriber subscribe to particular topic, client can exchange message with the topic. So you can see that these are the subscriptions, right? This create and close. So once your subscription will be created, create and close session will be created as well as here only. So as you can see that this is a transient subscription. Transient means, as you can see that here once it will be create and close, then again gap, create and close. So in between constantly you are messages you are receiving, you cannot get it. This message has been dropped. But as you can see the durable, right? In durable, as you can see that these messages are not lost. It will be long live subscription messages are there, right? And session will be smalls. Clear? Right. So once it create a session, as soon as it will get it. So session will be created for M1, get it. This session is not created, but once it is created, MT will get it. Likewise, it is happen. These are the header message type. Again, which type of message are you sending? 4 bytes. Duplicate message are you receiving or not? It will be handled. QoS level that I will explain. And retain is also there, right? That is I also explain later when I explain this. And remaining length 4 bytes. So these two are basically MQTT fixed headers. This is needed based on the functionality, clear, or based on the application you are running using the MQTT. You need this, but these are the basic things that needed. So these are the message types, right? So as you can see that I explained the CoAP that once you use a CoAP protocol, right, you have to use a get, post, put, delete, this type of messages, right? Here they have several messages like first reserve is there, for connection, connect is there. Then you want to send the acknowledgement of the connection, then connection acknowledgement is there. If you want to publish some data, publish is there. If you want to acknowledgement of publish, publish acknowledgement, right? This was subscribe, subscribe acknowledgement, unsubscribe, unsubscribe acknowledgement, ping request, ping response, and disconnect, right? And with the code. So these are the code it will be used in this. So 4 bytes, 4 bits are there, right? 0, 0, 0, 0, right? And basically how many are there? 15. So you can see that starting from 0, 0, 0, 0, 4 bits to 1, 1, 1, 1, right? 15. So this is why the duplicate message is detect the duplicate message or not, right? QoS level. So basically MQTT provides the quality of service, right? I will show you that what is the meaning of quality service and how it works using a diagram, right? So basically MQTT provides a 3 type of quality of service. First is 0. It is called at most once. Why it is 0? Because here you can see that 2 bits along with QoS. So 0, 0, 0, 1, 1, 0, 1, 1. Correct? So 0 means 0, 0. If you said 0, 0 means at most once delivery, there is no guarantee. That is means fire and forget. Do it, send it, forget about it, you will get it or not. Like your message is delivered or not, you are getting acknowledgement or not, there is no guarantee. First is at least once delivery. At least once means your delivery should be acknowledged. Clear? Whatever you are sending, right? Whatever you are sending, the delivery will be acknowledged, but other things not sure about it. Now, second is exactly once delivery. Exactly once delivery. We will see later by using this diagram that how it works. Retain, right? So now the retain is that something like all of you are using a WhatsApp, correct? Right? So in WhatsApp now they implement a feature something like your messages has to be disappear by after some days. Am I correct? Yes or no? So this same thing, same type of is happen in MQTT. Suppose you want to keep the last message receive, whatever message you are sending and last you are getting. If you want to retain the last thing, right, publish message, then you have to use this phrase. Okay, so you have to set this retain 1 bit 0 or 1, right, retain flag, and remaining length will be your optional. Clear? So now as you can see that a publisher, right, will send a publish message to the server, this subscriber. Okay, so publisher will publish a temperature value, so 78 degree, with the return message. So what it will do? It will keep the message with them, right? It is not thing. So if you set the return equal to 1, it will keep the message. Then it will publish the value to the subscriber, right? And whatever subscribers are there, you will send. So this A subscriber will subscribe to the particular published topic, so it will get the notification. Subscriber will subscribe it with the subscribe message. Server will get the acknowledgement. Okay, you are subscribed to the particular topic. This is your acknowledgement, right? Now, after, because subscriber B is not subscribed previously, only subscriber A is subscribed, so only it will get notification. But once a new subscriber, right, once a new subscriber subscribes to a particular topic like this, right, and once it get the acknowledgement, after that it will get all the data. So now basic example I am giving you, like suppose you are new and someone publisher create a YouTube channel long before, clear? So as you can see that if you recently subscribe to the channel, you will get notification of all the videos they purchased by 2 months or 3 months or 2 days or 7 weeks, correct? So these are the things. Publisher has so many values, right? Server has so many things. But once you new subscriber will get, it will get all the notifications. So here as an example, this subscriber will subscribe. After getting an acknowledgement of the subscription, it will get the notification. Before that, it can't get it. So likewise, I have a message format also. I am not going to read it. It will take too much time. So message format type, as you can see that it is a connect message type, right? Which are the fields. You can go with this, right? I am not going into the detail because it takes too much time, right? Each and every protocol. So I am just showing you that each and every message, like connect message, then connect acknowledgement message, publish message, public acknowledgement message, public release message. Sorry, release message, here is the recurrent message, then complete message, clear? Then subscribe message. These all have a header format, clear? And based on that, it will work. Clear? You can go into the detail with this PPT. I will provide this PPTs to Nilesh sir. Okay, he will send you. Now the main thing here will come, QoS level, right? So basically it will work on TCP. There are QoS 0, 1, 2. 0 means at most once delivery, at least once and exactly once. So let's see what happened, right? Let's see what happened with this. We will see that first. So QoS level 0, at most once delivery. So message are delivered according to the delivery guarantee of the underlying network TCP/IP. For example, so temperature sensor data which is regularly published. So now take an example that you have some devices and is constantly publishing the data, right? So loss of an individual value is not critical since application will anyway integrate the values over time, and loss of individual sample is not relevant. Now suppose you are sending data, right? Publisher is sending the data to the server or subscriber, clear? Now sometimes it may be possible that, right, that data is delivered or not, that data is delivered or not, that is not bother about it, clear? If you are sending 100 samples and you are taking the aggregate of that, right, you are sending the 100 samples and you are taking the aggregate of that, clear? 1 or 2 samples has been lost, doesn't bother about it, because you are taking the average, clear? This is at most once delivery. Now QoS level 1, which is called at least one delivery. So messages are guaranteed to avoid they may be duplicate, right? So now the thing is that suppose you are sending some data, right, and that message has to be delivered, right, to the server or subscriber, and once you get an acknowledgement also that message has been delivered. But sometimes between the open and close connection your packet has been dropped, clear? You cannot get an acknowledgement because of that. What happened? You thought that this is fine, my packet has been dropped, I have to send again. Right? You're thinking like that. My packet has been dropped. I am not getting acknowledgement. Let me send again. So you are sending again packet, but your subscriber is already have. So that may be a duplicate message available. So by using the message ID, you will do it, but at least once delivery has to be happen. Now exactly once means these are highest levels, right? It may increase too much overhead, right? It means too much overhead, and mainly thing is that it's combined with of at least once and at most once delivery guarantee. So you are getting too many duplicates value and create an overhead. So now let's see this uh, how the lifetime or transient subscription will happen with the connect subscribe. So client and server will be there, right? So TCP connection has to be set up, right? So then after client send the connect message with session is equal to 1. So this session is equal to 1 means session lifetime created for the create message, then it will be acknowledgement, then subscribe to topic XYZ, right? This will be created subscription lifetime, subscribe acknowledgement. Clear? Your client will be a subscriber. Clear? Now, once it will be published or receive message particular topic. So many publish receive message has to be done, right? It will be done, then it will be unsubscribed topic XYZ. So your subscription will be end lifetime, but your session lifetime is still continue. Once you unsubscribe, right, you get an acknowledgement and then disconnect happen, then your session lifetime will come. So session lifetime and subscription lifetime has to be understood clearly. Clear? Same with the here also, which is the durable. So as you can see that subscription lifetime is created too many times. Once you send the disconnection, session lifetime is over, but it's terminate the session, right? Disconnect is not subscription. So these are the things that you have to follow. And now the thing is that with the QoS level 0. So as you can see that once client send the server a published message with QoS level 0, means at most one delivery, client delete the message. But when to delete? Client delete the message. So first will be publish. Once the subscriber get the published message, it will delete. It will go, it will delete. Now at least once is first client store the message. Why? Because if it is not delivered, then it is to resend. So client has for at least once delivery, client has to store the message, right, for QoS 1. Again at the server side also it store the message, right, because of the, if this has to be broken, then client has to resend. If this has to be broken, then it cannot go back to the client. Server can automatically send to this. Clear? So it is also store the message. After publishing, server will delete the message. Once the acknowledgement is get, it will delete the message. But here, delete. Once it is sent, delete it. It means publish, delete. You cannot wait for acknowledgement. Right? Now the thing is QoS level 2. 1 0 and 1 done. QoS level 2. So QoS level 2, as you can see that client will send store also, publish with QoS level 2, again store, publish. Once you get acknowledgement for recurrence, then you can say that release, right? After releasing command, right, you are deleting this message, and after publish complete message you are deleting. So here you can see that once it is published, it is automatically delete, and once you get the acknowledgement, automatically delete. So message type is only used publish the subscriber and publish acknowledgement. But here you can see that 3 messages are create more: publish current, publish release, publish complete. Right? So it will create additional overhead once you used with the QoS 2, right, in the network. So it's a ping request, how it will work. I'm not getting into the detail, right? You can go to this topic, wildcard entry, all the things. So this is a topic wise. So wildcard means all the topics, right? So plus and hash style will be used for wildcard topics. Clear? And now the thing is that MQTT works on top of TCP. So all the functionality of TCP, it will be handled by your MQTT protocol, right? You cannot worry about any functionality at application layer like QoAP. QoAP you have to handle reliability also, congestion control also. All the things has to be at application layer because underlying is a TCP. Oh, sorry, UDP. But now in MQTT what happened? Underlying is a TCP, so you don't have to worry. TCP can take this challenge and do it at part. You have to only worry about message transmission and all the things at application point of view. But the new thing is MQTT-S, or you can see that MQTT-SN, clear, which is for sensor network, which basically use UDP as an underlying transport layer protocol. Clear? So the main thing is that now MQTT SN, all the things you have to handle at application layer, even reliability also and all the things. So this is the thing about the MQTT, right? I am not going into the detail regarding this. So if you have any doubt regarding MQTT or CoAP, you can ask me right now. Then we will move on to the new. Any doubt regarding CoAP and MQTT? I'm not going into the detail because of time constraint, right? I have only 2 hours, and in 2 hours I have to cover for 5 protocols uh, as well as the implementation, the demonstration of CoAP. So I am giving you the overview, right, of that protocol. Not going into the detail of that protocol. If I will go, it will take too much time. So let me know if you have any doubt about CoAP and MQTT. I'm pausing here for just 2-3 minutes. Okay, just hold for a minute. I will come. So, am I audible, right? Hello? Hello?
Yes, sir, you are audible.
Okay, fine. So now, if you don't have any doubt about CoAP and MQTT, let's move on to the new protocol, which is called DDS, which is called Data Distribution Services, right? Which is a data sharing standard, right? Because you are working with IoT and so much data has to be generated. So this is a new protocol which is called the DDS, right? Which is Data Distribution Services, is an object management group standard. OMG standard has created this protocol, right? Which is efficiently used for sharing of data. It provides security, right, and all the things. So they have used, either you can use UDP or TCP based on whatever transport layer protocol you use. That doesn't bother about. It will work like this. So there are version 2.1, 1.4, and DDSI will become with version 2.1, right? These are the standardization. It will come. So how DDS is different or better? So as you can see that it's the same way, right? It's the same way like topic is also there like MQTT, clear? QoS level is also there, but here as you can see that for particular topic a particular QoS is already defined, right? For particular topic a particular QoS level is already defined. So if your topic for this for QoS is fixed, you don't have that much option. Clear? So now we provide a distributed data space, right, where application can autonomously and asynchronously read or write data. So global space is provided for you. Whatever writer can use it, it should be write the data on top of it, means publish, or you can say that simply push the data on top of it. Clear? And reader who want to get the data or read the data, it will read it, right? So this is a application point of view, asynchronously read and write happen, right? Now data centricity is one of the main thing. So if you work with data centers, right, so value the model work, right, as per the complex definition, right? So several data models, right, it will work based on the lingua franca, right? It's a model name, right? And it will be upgradable also, and continuously update will come. So what is topic? So here topic is, it's different than MQTT, but what is the topic defined here? Something like a domain-wise information class. So as you can see that, suppose I want to publish a census data. So census data, right? Temperature census data, it will be one topic, right? Pressure census data, it will be other topic. Yeah. So this will be type will be different domain-wide. Topics name should be there, and topic is defined by means of name also, type also, QoS level, tuple. These are the tuple. So if you work with the Python, you know tuple. So tuple will contain name, type, and QoS, right? Name will be the topic. Sorry, name will be the topic of the domain. Type will be the language type, which programming language you associated with this domain, and collects QoS, right? Whether reliability or persistence. So now you see that when you have a example like your home, right? Smart home, and you have a many appliances. Each and every appliances have a particular topic. For example, right, which is called singleton also, right? It is called home is called a singleton, and have a multiple instances like your appliances, right? And each tuple has a each key attributes have a tuple key, right? Based on that you can identify that. Now how it can work? So as you can see that structure has to be created for the temperature sensors, and it will store with the ID, temperature, and humidity value, right? And these are the structures we will create. So these are the things is basically used when you work with the database, right? And when you use the DDS protocol. So mainly people use cloud services, right, for this type of awareness, right? DDS protocol, the data distribution. So cloud services will be easy, right, because they provide you so many things: data distribution, data gathering, right, aggregation, right, segregate, all the things has to be provided by cloud services. So it's good to do, but sorry, but some of the implementation are like that, like researchers want to implement or handle the data right at the client side. Right. So what it will do? It will implement such a way that database has to be maintained, handled in such a way, right? So as you can see that this QoS policy, so durability, history, lifetime, user data, topic, so many things are there. Clear? Based on that, you can select quality control, quality of services for your data, and you can receive it. Now, QoS model, how it works, as you can see that this domain participants will be joined based on their ID. Again, same publisher subscriber are there, right? Publisher publish for the partitions and consume from subscribers. So what is QoS will be used because you select this many functionality. Clear? The policies has to be selected for QoS. This will be handled. It will be said. So data should be right, which offer this many quality of services policies, and reader has to be requested for that quality of any of that or some of them or all of them. Right. So particularly read write happen here, read write happen, right? But your services should be have some policies, and that policy or that constraint has to be not constraint, that request has to be sent by the subscriber that I want this, I want this, I want this. Right. So these things will be selected, policies will be selected by the publisher that I am publishing offering this type of policies, clear, or this type of services. But as subscribers, as a subscriber, you have to fetch that you read all or you read some of them. Clear? So based on that it will work. Delivery. So data delivery is one of the college policy, right, which contains who delivers the data, right? Who delivers the data, where the data is delivered, and how the data is delivered. These three questions should be there, right? Then it will work. So who delivers the data? It will contain the ownership, right? Right. Next, where to deliver data means partition has to be done or not, and how. So is there reliability is there means you get acknowledgement for deliver the data or not. Destination is particularly fine to deliver the data. How it data should be reached there. Presentation, is there any corrupt data or full data, right? So these are the things to be done. Now data availability. So as you can see the temporal decoupling will be history and durability, and lifetime means validity. And in temporal property, you can see that inbound, outbound throughput means latency, right? Inbound throughput means throughput. Throughput will be used time-based filter apply, and the latency, how much deadline and transport potential. These are the thing, and cloud and fog, sorry, cloud and fog and edge computing will provide this type of communication device to device and device to cloud. Security is already there, and DDoS is performed by, you can use any of these languages or operating systems, right, or any architecture that you work on the particular hardware. DDS has independent of that, so you can use any of that. Just try to code it, right? You want to use fog and cloud, do it. It's your choice. You want to implement your end client side, you can do it. So this is the DDS protocols. It's not that much in detail. Any doubt regarding this? Any doubt regarding this DDS? Because it's basically data distribution services. Whenever you want to handle with the data, right, you have to take care about the data by using this, right? Data distribution services. Any doubt? Okay. So if you don't have any doubt, let's start with this new AM, AMQP protocol, Advanced Message Queuing Protocol, AMQP. So now, just hold a minute. So sorry. So so before starting this expert lecture, I explained about communication model. Clear? One is request response. One is publish subscribe, right? One is WebSocket based, and the last one is called push pull, right? Push pull. So AMQP is the name itself suggested advanced message queuing protocol. So what happened at advanced message queuing protocol is that client is also there, or you can server or publisher subscriber is also publisher subscriber, but you can say client is also there, server is also there. Clear? So whatever the client will send, right? That AMQP also contains the broker. So let me check whether we have a something whiteboard or something here I can draw. Oh, I don't think so. We have. Mhm. So now the thing is that let me explain by sorry diagram here. If I have it not, the thing is that in AMQP client is also there, server is also there, right? Imagine that the same diagram like publish subscriber. Client is also there, server is also there, in between broker. So AMQP also supports broker. Clear? Also supports broker. And now broker will contain the queue. Here, what broker contain in MQTT is topic-wise database. Topic-wise database, nothing more than that. But in AMQP, it maintains the queue, right? Queue. So now, client want to publish any information, right? What it will do? It will push it. It will push it to the queue. I think data structure, right? In data structure, what you do? Something like NQ or DQ something, right? Correct now? The same way here, client will push the data to the queue. So this is your something like a broker here. This is client. This is server. So broker will contain the queue part. So client will push the data to the queue. Now queue maintains all the data, right? Queue maintains all the data. When the server wants to information, it will simply pull it from the queue. It will simply pull it from the queue or broker. Clear? So AMQP supports push pull communication model, right? OAuth supports request response. MQTT supports publish subscribe. DDS also supports publish subscribe. AMQP supports pub, sorry, push pull communication model. So why should you care about that? Because many of the integration, or you can say the project that industry handling, right? Most of the thing it's about cost, right? Costing has to be good or bad. That's the main thing. Wait. Costing has to be more for the project. So why messaging be needed to transfer the data from point A to B? Asynchronous manner. MQTT is also doing asynchronous. DDS is also doing asynchronous. CoAP is also doing asynchronous. Right? Right? And decouples the publish subscriber queuing for later delivery. Later delivery. Why queuing is important? Sometimes it's used for later delivery. Right? So limitation of existing is that one IBM MQ, and these are the message queue telemetry transports. So proprietary middleware has been a source of lock-in. Interoperability is main issue. and language and cross-platform independence. That is also main issue. So application level bridging is needed. Clear? So two vendors are, see here, two vendors are make Linux based applications, right? And one vendor wants to this for proprietary, one vendor for proprietary for this. Suppose like I want to build an application, but I have so many functionality and one vendor cannot support it. So I will go for two different vendors, right? So application bridging is very useful when you have a different types of functionality in that, right? So AMQP is considered by JP Morgan around 2006, and it's provide a vendor natural protocols, right, which have all this cross-platform functionalities. So how does AMQP solve the problem? So as you can see that it's GSM, it's a wire level protocol, is not an application programmable interface API. So as you can see that is an JMS is an API that uses, and just like as HTTP in the internet, AMQP is also used. So these are the industry supports of AMQP. These are the companies they have a support of AMQP. Now the concepts, right? So in concepts, you can see that the virtual host to be created. Again, the publisher and consumers are there. Broker is also there. Virtual host. The exchange messages is also happen. So one block is for exchanges, right? So whenever publisher or client, you can see that publish any message. Clear? It will go to the exchanges. Exchanges will use to exchange the message, and then it will store in the queue, and from queue consumer will pull it. So it will push to the exchanges and consumer will pull it from queue. Now each virtual host comprises own name. So this virtual host, which is own name will be created, right? Space is there, set of exchanges is there, clear, queues are there. So this is a virtual host in the server. So your server have so many space, right? So for each push pull notification, the several virtual hosts to be created, right? So publisher will publish to particular host, right? Such a like topic, it's like topic. For particular topic, host is there. As per my terminology, you cannot use topic as a terminology, but I am related to this MQTT one, so you can understand that. So for each and every host to be created, exchanges and queue are there for each and every host. So it's much like a topic. Right now, how the producer consumer work? So as you can see that producer will produce some messages. It will go to the separate queue through exchanges. So exchanges will decide where to bind it, which queue the message should be bind, and at the consumer side, all should be gathering and segregate and send it to them. Sorry, aggregate and send it to the consumer. So now the main thing is you have to understand here why this is 3Q. What exchanges will clear. So what exchanges will do is, if you maintain the single queue, all will publish the queue, your queue will become full, and packet has to be dropped. Clear. So again there is the same problem. Packet has to be dropped. Again you have to send the producer, inform the producer, yeah, I'm not getting this thing. What do you want to do? Again send it. Again time consuming, latency, bug requested. So many things happen. So what they are doing is simply maintain a different queue for particular things. So based on that, it will exchanges will do the bindings, and at the end it will aggregate. Now the thing is that exchanges receive the messages from the publisher and routes this to the queues. So binding define the relationship between the message queue and exchanges and provide the message routing criteria. Now the fan out exchange is there. So fan out exchanges means that messages to every queue. It is called the fan out. See, directly. See, it is called every queue bound exchanges. Now there is in fan out exchange key type, no routing key is needed. Whatever must in, it has to be go out. Clear? Now the direct exchange, right? So if you define message has to be defined some key, right? And each and every queue has key. So once you say that my message, what happened? It will send a message to queue which has marking specification is there, and it will to get you one. So queue will be used string is a direct exchange. Use string as a routing key. Queue binds to exchange with the key R, key K, key R, send a message to R, K equal to R. These are the things and you direct access means AMQ dot direct is to be always pre-created host. So as you can see that these are the messages with different routing key, and these are the queues for different routing. So as you can see that each and every one goes to the start with the USA key, whether it is news or weather, it will go here, right? If so, two types of routing key is there, right? First, it's a USA, then anything will be in the USA, it will go here. Anything will be the news, irrespective of the country, it will give here. So there is a key value binding pair, right? So whatever the key is there, based on the key also have some value also. So objects, key dot object, something value is there. It is based on that it will classify. So whatever comes in the US, it will come here. Whatever come in the news, it will come here. So each and every things are there, the binding key. Now the thing is that it will be the consumer. This consumer has to be decide what you want. If you want all information related to the news, pull it from here. It will all the information related to weather, pull it from here. It only wants USA based information, pull it from here. It only wants Europe based information, pull it from here. So this type exchanges will work on it. This topic exchange is how it works. These are the implementation of broker and client implementation. You will find it. RabbitMQ is the most what we say that used implementation of the AMQP. Broker, correct? Broker. I am not talking about the client, right? So client side you have a two implementation, C++, broker side C++ and Java. Client side you can use any one. C++, Java, JMS, Ruby, Python, C# as per your specialization, as per your mastery. So these are about the things about AMQP. Any doubt regarding this? Then we will move on to the XMPP. Any doubt? So now let's move on to a new protocol which is called XMPP. So I am XMPP, right? It's an extensible messaging and presence protocol. It's specially used for messaging. So it is also already standardized by IETF, right? MQTT, AMQP, DDS, these are the protocols are not standardized by IETF. Only COAP has been standardized by IETF. So they have a separate foundation, XMPP Standards Foundation, and membership base that you can use it. So these are the RFCs for XMPP core, instant messagings, then the common presence and instant messagings, then end-to-end, right? For end-to-end signing and encryption, you can use it. For URI, you can separate RFC, URN, you separate RFC. So these are the things. Now, what is XMPP is that it's basically use TCP, right? Underlying TCP, and it's a real-time exchange. If you want to send a structured data, right? Structured data, real-time structured data. If you want to send client to server or communicate over the internet, you can use XMPP. Clear? So its presence, out of the box feature of XMPP includes presence information and contact list maintenance. So XMPP maintains, right? It's maintain the state. What are the state information is that the presence information of the particular clients or particular things based on the contact list. So also extended, you can say that publish subscribe systems. It's not perfectly publish subscribe system, but extended. Right. So now you can see that XMPP architecture, you can see that there are three servers. Server 1, server 2, server 3. Clear? So one particular set of client connected to server 1, other particular set of client connected to server 2, other particular set of connected to server 3. Now, if client want to communicate with any of the server 1, server 2 or server 3, they are specific using some port 52222. But if server to server want to communicate, they use 5269. Right. So these are the architecture. As you can see that something like user addressing scheme, they use something like user at the rate domain at the rate home. User will be your node name, domain name, whatever the laptop, and home. The home means the resources, right? So these are the addressing schema they use, and these are the things they use. I am not going into the detail about it, how it works, and just explaining it. So these are the domain. In this domain, your one resource is there, and in other domain, right, other resources are there. And this two domain has to be transformed with the structured data, right? They have used the XMPP. Clear? So now these are the things how can you use it. So you can see that you can use XMLNS, right? These things are already knew about it. So these are the ID. Then you are sending this request with English language. Some ID is there, and these are the values of this tags. So this is basically called the tags, right? So HTML tag, and see you are using HTML tag. So body tag, inside that attributes are there. Same way, is also work. So now here you can see that here once you send a tag with a geolocation, clear, tag with this geolocation about the zebra.org and protocol, whatever things you are sending here, it's not worry, but this is basically tag for geolocation. So it will attributes are like latitude, longitude, locality, region, right? These are the attributes in that. So these are the called the elements of that, right? And these are the called the attributes. Same way, socket server communications and all the things. So these are the terminology they use XML, right, for stream based or anything you want to send. So I'm not going into the detail. The only thing you have to worry about is features, stream features. These are the features, how to use a particular element inside it. These are the way, and separate RFC for that. So if you want to go to the detailed implementation, you can go into the deep, right? But if I explain in detail, it will take too much time, and it's totally implementation based. Totally implementation based. So you don't have to worry about it. Once you want to do implementation, you have to do. Now the thing is that where to use XMPP, right? Where to use XMPP. Now suppose you want to transfer some data, but instead of raw data, you want to transfer some using a format, and your browser or anything want to understand that, right? At that time you can use XML. So they have a bandwidth minimization, latency also, several fonts are there. These are the readings you have to read, advantages, disadvantages. These are the things is needed for XMPP, right? Based on the time constraint, I am not going into the detail because I have to show you the implementation part also. So, right, by using this, I just covered a brief introduction about the IoT protocols. Clear? Brief introduction about the IoT protocols. Now tell me if you have any doubt regarding this. Any doubt? Any doubt?
No, sir.
Okay, fine. So you can contact me or mail me any doubt if you have, right? In the future also, and if you are doing some implementation, you can ask me. So now let me show you the demonstration of the CoAP protocol, right? Because MQTT, we need a broker also, clear? Let me, if I have a MQTT, if time permits, then I will show you the MQTT also, clear. But if time not permits, then co-op is fine. And because MQTT demonstration and detailed explanation, because I skip so many parts of MQTT header and all the things, there is need a separate lecture, right, to explain about MQTT things. So co-op also needed, right? I just finish in very quickly. Co-op. So let's start with the implementation part. So main thing is that there are three ways to do it. I am using instant Contiki. So Contiki is a real-time operating system for IoT, right? Likewise, there are many operating systems. You can say that Riot is also there, right? Riot is also there. Then Ubuntu has a separate operating system for that. Ubuntu has a separate operating system for that. Microsoft Windows has a separate operating system for IoT devices, right? Likewise, real-time FreeTOS is also there, FreeRTOS. So likewise, so many operating systems are also there. I am using a Contiki operating system, which is available freely. So there are three ways you can start with this Contiki operating system. First is, if you are beginner, you can go with the instant Contiki that I am showing you right now. So my screen is visible to you. Does my
Yes, sir.
Okay, so how to go with the instant Contiki? Let me show you. So once you go, so just start this instant Contiki download, and you will go to the sourceforce.net, right? So if you are a beginner, clear, you can download any of the version that you want to work. Latest is 3.0, right? That is the worst version, instant Contiki 3. Don't click on it this, because it will download 2.7. If you want to work on 3.0, click on it, it will work. Clear? Now this is the simple thing, right? Instant Contiki version. But another thing is that suppose you want to work on a source code part, right? And you already familiar with the Contiki, then you can go with this, right? A Contiki. This is a source code. Clear? What instant Contiki will provide? Instant Contiki is a image, virtual image. Clear? So for this opening the instant Contiki, you need either VMware player or VMware workstation or VirtualBox to open it, right? And this image contains the Ubuntu as well as Contiki as well as all the packages that require. So you don't have to worry about, as a beginner, you don't have to think to install so many things. Just download, install Contiki and work it. But if you are good familiar with it, then you have to go with this. Wait a minute. Contiki folder and download any one of this. Okay, here 2.7 is there, latest. 3.0 is not coming here. But if you want to work with 3.0, another thing is that you have to go to the GitHub, right? Contiki GitHub repository. So if the Contiki GitHub repository is there, wait a minute, it will, this is the official GitHub repository of Contiki. You can download the development branch here, right? You can clone it by using GitHub ID, and every few days you can use the push pull if you know the Git very well. So latest implementation, it will pull from this repository to a local one. You can do it. This is the master branch, or you can go with any release. 3.1 is also coming, so you can click on 3.1 branches, 3.1. This is version 3.1. You can again clone it, right? You can again clone it and do it. Okay? So this is the way you can do it, right? Three ways. You can use the GitHub version directly, you can use the source code or instant Contiki. So I am giving a demonstration of using the instant Contiki. So how can you do it, instant Contiki? So see here, I have downloaded the instant Contiki here. This is instant Contiki 3.0, and I have extracted here instant Contiki, and by extracting this, you will get only 2-3 files, not these all files. Huh? Remember this. You will get one VMS, except this 2-3 files are there, right? So you have to open this VMX file, right, which contains Ubuntu 12.04. So I am using the VMware workstation, right? So once you open this, go to the file, right? New virtual machine, right? And after creating a new virtual machine, you want to do a typical and you have to set the image, right? Here you have to give the path to the VMX file, this VMX file, and next, all the things will work, and then this will create it, like here. Clear? So now this will be created, you can just here click on like this 2.7, but here you can click on power on this virtual machine for 3.0, and it will like this. This will contain Ubuntu also, and this is a UI part that you can get it. Okay. Now you say that what is the password, sir? Because it's already image. So by default, username is instant conti key and password is USER, user. USER, user. So once you click it, yes, once you click it, you can see here the terminal will be open. It will work. Wait. This is a terminal of that. Let me minimize it. Go to the places, home folder, and the thing is that here you can find a folder. So this is a Contiki folder, default Contiki folder. You can see here, right? All the things, software and all the things are installed. You don't have to worry about it. Clear? All the things are there. Clear? So now this is a Contiki and these all are folders, right? Suppose you want to work on CoAP, right? So in application, this apps means application, several application layer protocols and their codings are available. So you can see that for CoAP they use ER-CoAP. So Contiki supports C programming based RBM framework, right? RBM, ERBIUM, ERBIUM, RBM, right? RBM CoAP, it supports framework Contiki. These are the things, functionality of CoAP, configuration, basic coding, right? Constants, right? How the packet has to be sent, the transaction file are there. So each and every application, if you want to work on FTP, there. If you work on HTTPD web services, code is here. JSON file, MQTT, code is here, right? DHCP. So each and every protocol applications code, not protocol, applications code is available here in apps. Now you can go with this core part, right? So core part, if you want to work with the routing layer, so you can go to the net and you can go to the RPL, because RPL is mainly used for routing protocol. This is RPL file, clear? So in RPL, so many files are there. You can work with the DAG is there. These are MRHF and zero objective function is there. So RPL is also part of the routing layer. So as you can see that the stack layers down physical layer, it will come with IEEE 802.15.4, right? Physical and MAC. Then it will come at the data link layer, right? Then it will come as the adaptation layer, which is called 6LoWPAN, right? And then it will come on top of that, it will come network layer, which is called the routing layer also, which is next to the RPL. It will also use IPv4, IPv6, all the things it will be there only. And then on top of that, it will come transport, TCP, UDP, and top of that application. So irrespective of the application layer protocol, right? Routing is used fixed, RPL. You use any application layer protocol, routing layer protocol is RPL only. Correct? So code will be here in core net. Clear? There are other than file, development file, library file, loader file, right? These are take too much time for demonstration, so I am giving you fast. Then microcontroller units that you want to work, like CC2430, right? MSP430, right? These are the microcontrollers names, STM32 controller, and these are their codes. Clear? So you want to work on that, you want to go to this, and several inbuilt examples are there. Suppose you want to start working on it, no problem. Start working with the inbuilt example and then move on to create your own example. So now Here you can see that inbuilt examples are there. So here we have for co-app, we have an example called RBM REST example. Right? We have a code called RBM REST example. REST is a representative stateful transfer. Is already there. RBM REST example, which is using a co-app by default. I will show you the code and then likewise several codes are here. Examples, Qubit examples are there. You can go with this. Now you want to upload the code, right? So you need a platforms like nodes, right? So for that you need a platforms like Sky Mode, Zero Mode, and several other modes are there. At Mega microcontrollers are there, Raven microcontrollers are there, clear? Then STM32 microcontrollers are there, CC26 series microcontrollers are there. See here. So all the platforms code is here. By default configuration is here only. So Sky Mode configuration is here. Clear? So this is a configuration they have used. So in detail, I am not going into detail. Once thing is it, and one more thing. As you can see, the pop-up will become update it. Please, once you download the instant quantity, don't update it. Clear? Don't update it. Do not update it. Anyhow, just click on remind me later. Otherwise, it will update. You cannot run some few of the examples. Right? One of them, then I am explaining to you. Now, these are the contents is called operating system. On top of that, right, on top of quantity operating system, it provides a simulator, right, which is called a Kuja, right, Kuja simulator. Clear? So it will be here. It's a Java based simulator in tools. Then you go to the build. Where is build? No, Kuja. Then build. This is jar file, not build. Where is this? Dist. So you can see that jar file is there. That will run a simulator. So I will show you that how to open the simulator. So you have to open the terminal. Is it visible? The font are visible to you? The font are visible to you, students?
Yes, sir, visible.
Okay. So now here you have to run with the sudo permission, sudo and jar, right? So and is a package that quantity is used to compile it. If you use the source code part, you have to install all the things packages. So let me show you. This is the site anrg.usc.edu. Clear? It will go there to the www. You have to config it or type it Contiki, Contiki tutorials, and these are the examples and steps are there. So in installation, you can see here, if you download the source code file, right, you need to download or install this many packages. After that, you have to set the JDK path also, right, because it's a Java based simulator. So you need to set JDK part also. Right. So if you download the source code, you have to do this type of work and then it will work. Right. But instant quantity directly. So you now use the sudo and jar password of same user only. Oh, sorry. I am not going to the Contiki. I have to go to the Contiki, tools, Kuja, and then jar file, because jar file is in Kuja. Right. So if you have installed all the things correctly, you will get a message build successful. If you not, then build unsuccessful, an error will come here. Now you have to run the simulator, sudo and run. So to compile it, sudo and jar, right? I will show you here. Sudo, go to this directory, Contiki tools Kuja, sudo and jar for compiling, and sudo and run for open the simulators. Clear? Simulator. Now simulator is open. This is simulator. So by default, so many examples are there. You have to open that example. No problem. Right? So I am opening it. This hello world example are there. So in that, see, I am using 3 nodes, 1, 2 and 3. This is a hello world example. So If you open the by default example, no, then go to the new, you have to remote it. In new simulation, you have to give the simulation name, whatever name is there. So I am giving a name demo underscore and the radio model. So how the radio environment should be worked to transfer the messages, right? It's based on the distance loss, means once it is in this range, distance loss means it is in this range, then packet should be delivered. If it is out of range, packet should not be delivered. Constant loss means fixed loss. Whether you are in range or not, this many loss happen. Directed graph radio medium, there is different for that. If you want no radio traffic, no problem. And multipath rate medium. So this again take time, so I will use the distance loss and create these things. Now I am giving a demonstration of OF protocol. So what I will do is here, I will take a router, right, a border router. It is called a terminology border router, but it's a router. Server is here. I will deploy a server also, but I am using the client which is called RBM CoAP client. Clear? RBM CoAP client, which is already available. Right here, you go to the application, internet browser, Firefox. If you open the Firefox, you can see that here Copper plugin is there. See here, start Copper CoAP user agent. Here, it is a CoAP client. So I am using this CoAP client plugin from browser. I am sending a request and get the resources. So let me quickly deploy this. So you need a mode to upload the code. So I am go to the modes, add modes. I am going to the quickly because of time constraint, because already 11:57 I have to finish it. So Miller sir, I am taking, or ma'am, I am taking 5 to 10 minutes more. Is it fine?
Fine, sir. It's fine.
Fine.
Not
Okay.
an issue.
So, okay. So now the thing is that you have to go to the modes, right? Then create mode type, and I am selecting the sky modes for the border router. So I am naming the naming of that border router, and now you have to use the firmware. The firmware is nothing but your C file. So what you have to do, go to the home, user, config key, right? Inside that examples, and for IPL border router, the code is in IPv6 because IoT protocols work on IPv6. So IPv6, then RPL border router. Go to the IPL border router, then border router.c file. This is a firmware, right? So open it, select it, and if you want to work with the command line interface, like here, right, like here, so you have to go to the that place, same way, config key, example, IPv6, then RPL border router, and you can see by C file here. So if you want to work with this, you don't want to work with this GUI, you can use this command to compile it. Make border router.sky target is equal to sky. Otherwise, make target is equal to sky. If you use make target is equal to sky, all the folders, C files inside that, it will convert to sky file like this. This is a binary file, right? This will be uploaded to the mode. So now I am compiling it. So see, compilation done. If you will find any error, you will find it here. You will to resolve this error and again compile it, clean and compile. Once you compile successfully, create it. Now it will how many modes you want. So I am creating one mode only. Positioning, which type of positioning I want. One mode, so random positioning, add mode. So here you can see that mode has to be added. And when I click on it, you can see that here sky1 border router.c file is uploaded. Now the main thing is that the green part. So here green part, as you can see, which is called radio transmission. In that green part, any node is that it will receive and send a message to border router. But it will go into the gray part. Gray part is called interference range. Right? It will interference the other environments. So now I will go to the mode type. So color combination will come. So as you can see that if I go to the view, mode type, the color combination will come. Now router is set. client is already there in Firefox here. So now I am using the server. So again go to the mode type, go to the create new type, again sky modes. I am using the server, right? So coapp server. Here now again go to the branch. So I show you that where is the code of example of this RBM waste example. You go to the server file example server.c, open it, compile it. You will find some warning. Fine, no problem because of some chipset, but it will enable the create button. That means you are able to upload it. So I can create a 3-node random positioning fine. So you can see that color combination is changed with the orange or yellow color. So you can see that one. So when I move on it, you can see that transmission range is 100. When I move, 0. So it will show like the transmission range of 2. Here 3 is not direct. I am just setting the topology. 3 is not in direct range of 1. It will transmit the message from 2 to 1, and 4 is in direct range. So I am creating a topology something like this. So as you can see that border router, so 2 and 4 are in direct range, 3 is in dot direct range, for 2, 1 and 3 direct range, and 4 is in direct range. So for 4, 2 and 3 are in interference, for 2 only 4 is in interference, for 3, 1 and 4 are is in interference, 2 is in direct. So now after deploying in that, after deploying this, what you have to do? You have to open the bridge connection, because client is different, server is different here, right? Server is in simulator. So you have to create a bridge. So for that, I am creating a serial socket server. To right click on the border router and go to the mode tools and create a serial socket server. This will open it and click on start. So now serial socket will be created. So for open a bridge connection, I will go to the Contiki example IPv6 border router and I will use make connect router. If you are using a separate mode, you have to use the mode only this type, make connect router, right? If you are using CUJA, you have to define make connect router CUJA and press enter. It will ask password, give the user. Now it is waiting for opening the connection, right? When it will open? Once you start the simulation, right? Once you start the simulation, it will open the connection and then you can communicate it. So let me start the connection here. So as you can see that each and every, this is a mode output. So this is a control panel. So each and every mode has to be loaded, right? Booted, not loaded, booted. And then you can see that socket to mode and mode to socket data. And here you can find that you can get the IP address of the border router. Clear? Now let me search, open this and I will search sending the HTTP request to border router. Clear? So what is my IP address of IPv6 address of border router? See here, same 888.212.740.1.101. Clear? It's a local, right? So I will enter it and you will find that neighbors. So which are the neighbors of the border router? Can anyone tell me here? The neighbor of the border router are 2 and 4. Clear? So here you can see that 2 and 4 IP address is same. So if you want to see the IP address of this, go to the view, click on view, address and IP address. So if you find that FE80212740222202, here 4404. Clear? So these are the two direct neighbors, and routes 2, 4 are there, direct connection 4 to 4, 2 to 2, but 3 is communicating via 2. So this will be represents a connection, right? How to do it connection and how to communicate it. Now let me send a COAP request, right? So it's called a neighbor discovery or it's called a discovery message. So what I will use, we are using, if you want to send a request, what we are using HTTP normal, right? To send the request, but here we are using COAP. What we are using? COAP. And IP address is C30C002. No, sorry, this one. right? 888-212-7403 2, or we can use node number 2 also, server, right? And I am accessing this only, right? So this will be the coap double colon slash IP address of node number 2 colon. So by default, after colon you have to paste the port number. So coap using the by default 5683 or coap S secure 5684. So we are using coap, so 5683 protocol, and I will press enter. Let me see. Yes. So this is called a resource representation of the node. Clear? So when I click on core and send a get request, here it will display which are the resources available to particular node. So particular node has a test message hello, it will print text message. Push notification is also there for periodic demo, and toggle LED is there. So let's start with toggle LED. So node number 2 I am accessing. Okay. So I will click on node number 2. I will go to the right click and show LED on sky 2. Now this is sky. Which are the LEDs available? Green, red and blue. Clear? So, and resource representation, only which LED is showing? Red. Other LED does not have, based on the representation. Clear? Now I want to change the things. Right? So I want to go to the actuators toggle, because LED is actuators. So toggle, and outgoing message more is equal to off. I will make it on. Clear? I will make it on. In some pages you will get more is equal to on off. In some you will get 0 or 1. 0 means off, 1 means on. So here more is equal to on, and I will send a post request. What I will send? Post. So here you can see that actuator toggle is open, right? And I am sending the post request to change the status of the LED. So I will send the post. You can see that 20505 content successfully message sent. These are the RTT, and saying here red LED will on. Clear? Red LED is on. Now I am sending off. Clear? Again post message successfully 85 millisecond. LED is off. Likewise, you can access any mode, 3, 4, anyone. Clear? So now hello is simple text message. So I will get request. So it will print hello world. Clear? So let me capture the packet also. So you will get to know that how to capturing the packet. I don't have a time. So if you want to capture a packet, so go to the tools, go to the review messages, click on it, analyzer, and just click on 6-low-pan analyzer with pcap before starting the simulation. Okay, 6-low-pan analyzer with pcap. So if you do it, you will find the pcap file here. Contiki, tools, Kuja, build. This is a pcap file, and if you open with Wireshark, Wireshark will be open, and here you can type the coap packet. See here. You can see here coap also is sending a packet, right? So confirmable message, I already explained, get request, acknowledgement with the content. And if you want to see the content, confirmable get text plain, right? So well-known core request is sending, see here, well-known core, here, in acknowledgement, resource representation, again same. So here, confirmable, well-known core, again hello world, same request. So you will find a resource representation here also. Clear? So confirmable and acknowledgement message is there, and here you can see that consent application protocol acknowledgement, the coap version header file. See version 011 acknowledgement 210 binary representation. See, right? And for confirmable version same but 000. Here I already explained. Clear? Then I explain the other file. So this is the way to see the demonstration of coap request and how it works. So any doubt regarding this, for detail, I need some time to explain it, right? And at least some detail, it take too much time to explain all the things. But in brief, within 2 hours, I hardly takes 10 minutes more. So hope I am able to deliver the content, right? And you are able to understand the things that I want to convey to you. So that's all from my side. Thank you.
Okay, so students, you have any questions? Students. Okay, fine. So, thank you, Vishal sir. Thank you so much. We are very grateful for the time and efforts you took to share your knowledge and the experience with the students. And regarding this particular IoT protocol, it was wonderful session, sir. And it will definitely help the students to understand that protocol. And we'll definitely plan such a kind of expert talk in future also. Thank you so much, sir, again. Thank
Yes.
you.
Thank you, ma'am, for inviting
Okay.
me, and yes, sir. Right. So if you have
Thank you,
students,
sir.
if you have a doubt, you can mail me anytime.
Fine, sir. Fine.
Okay,
Thank
sir.
you, sir.
Okay.
Okay.
Bye bye.
Okay. Bye,
All
sir.
the best for your future students. Bye bye.
Okay, bye. Okay, so students, I'll share one feedback form with you. Please fill up and please give your valuable feedback regarding this expert talk, right? I'll share in a chat that feedback form link. Okay, students?